So 11.2 is about series. If you remember, this is what we mean by a sequence. This is what we call series. So we are mostly interested in the same question, whether it's convergent or divergent, the sum. So we are interested in the sum of the sequence. Let's do a problem. AN is determine whether the sequence is convergent. So part A is to determine if is convergent. So we do it in the same manner. We calculate limit so you can factor out an n, cancels out, and as n goes to infinity, this goes to 0. So we're left with 2 over 3. And because limit exists, it's finite, so it's convergent. This is yes. So this was about sequence. Sequence, take the limit, finite, convergent. But now we want to focus on series. Part B. If so one test we can use to answer this question is test for divergence. So it will tell us about divergence. If not equal to 0. So if the limit n going to infinity an is not equal to 0, then this means the series is divergent. So if the limit n tends to infinity an not equal to 0, this means the series is divergent. And as we saw above, limit two over 3, right? This is the limit 2 over 3, and 2 over 3 is not equal to 0. So this means the series is divergent. So you have to cite this test by a test of divergence. So test of divergence implies that series. It's not. Let's do more problems. On 19. So this was the previous question. Determine whether the geometric series is convergent or divergent. Geometric series. And what is a geometric series? You have to remember this form. Sum n1 to infinity a times r to the power n minus 1. Now, if the absolute value of r then 1 divergent. If less than 1 convergent. So first thing will always be to figure out what is r. If it's greater than 1, divergent. If it's less than 1, absolute value, convergent. And when it's convergent, the sum. So in this case, the sum yeah. So when it's convergent, the sum is given by this formula. So absolute value less than 1 means convergent, and then this is the sum. So let's do This is the series given to us. So observe, if I factor out 10, 1 minus 0.2, let me write it again. So if I factor out 10, here we have 1 left. This 2 changes to 2 over 10, which is 0.2. 0.4 changes to 0.4 over 10, which is 0.04. 0.08 changes to 0.08 over 10, which is 0.00. So this is same as right, so this negative inside. So what we see is 1 is just 1, negative 0.2 is plus negative 0.2, 0.04 is negative 0.2 squared, negative 0.008 is negative 0.2 cube. So this is same as so this is the geometric series form. So from comparing these two, what we see is A equals 10 and R equals negative 0.2. Now, absolute value of R is less than 1. Thus, absolute value of R is 0.2. So converges or convergent. And the sum is given by which is same as 25 over 3. 4 3 are 425. So first we wrote this in our standard form. We found what is A and what is R. Because R is less than 1 absolute value, so it convergent, and sum given by this form. There is another way to approach it. We will see it in the next problem. The series that is given to us so this is it looks like a geometric series, and it's given that it is geometric series. So it is given that this is a geometric series. So this means n equals 1 gives us A. And n equal to gives us A times R. Right? Because geometric series is so if n is 1, we get A. When n is 2, we get AR. So let's see. So n equals 1 is -3. So A equals 1 over 4. N equal to -3. Right? When n is 2, it 4 square -1. AR. So R equals AR over A. If 3 over 4. This means convergent. And the sum would be then so the sum is 1/7. So we have to determine what is A and what is AR. So A is 1/4. AR is -3/16. And we found R, which is -3/4. Absolute value less than 1, which means convergent. Then we use the formula for S. A is 1/4, 1 minus R. So minus minus becomes plus. We have 4 plus 3, 7. And this 4 cancel out. Get 1/7. Let's do another problem. $37. The series that is given to us is we have to determine if it's convergent or divergent. That's the question. So we can start by using test for divergence. So observe AN is so limit. Let me rewrite it. Which equals and square will cancel out. means limit equals as n goes to infinity, this goes to 0, this goes to 0. So limit ln 1 over 2. Now ln 1 over 2 is not equal to 0. Right, limit to infinity an ln 1 over 2 not equal to 0. So this means divergent by test for divergence. Important to write. Very important to write. So writing test for divergence is important. If we conclude from test of divergence that this series is divergent, because the limit is ln half not equal to 0. Let's do another problem. Now, arctan is same as tan inverse. So we have to determine convergent or divergent. So we proceed in the same manner. An is tan inverse n. So limit which is pi over 2 and pi over 2 is not equal to 0. Therefore, is divergent. by test for divergence. So when you see a series that doesn't look like a geometric series, always check, compute this limit. And if it's not equal to 0, we conclude it's divergent by test for divergence. So one more problem. $43. So the question is same, convergent or divergent. One thing to note, right? Because as n goes to infinity, denominator goes to infinity, so this becomes 0. So this means test for divergence is inconclusive. So we cannot use test for divergence. Means cannot use test for divergence. So this is also a very important thing to keep in mind. That when this limit goes to 0, test of divergence doesn't say anything. Inconclusive. Doesn't say anything. When the limit was not 0, so when the limit is not 0, then it's divergent by test of divergence. But when the limit is 0, we cannot use it because test of divergence is inconclusive, doesn't say anything. So now we proceed differently. its partial fraction decomposition would be remember. So we can solve it easily. Just now you can do it. So next, what is given to us is we rewrite S as Sn. Now what is Sn? So we have changed from n to I. So n minus 1 is I minus 1, n plus 1 is I plus 1. And we sum from I equals 2 to not infinity, 2 to n. So this n, and then we take the limit n going to infinity, which will give us S, which is the original question. So we write this in this form, n is Sn, and we define Sn as summation from some other dummy variable 2 to n. So I is dummy variable, dummy index, or dummy variable. So now Sn is 1 minus 1 over 3 5. Now here I is n minus 1. Here I is n minus 2. So we stop here, like we choose to stop here. Otherwise we can like go on and on to any. So we choose to stop here at I equals n minus 1. Now if you observe, negative 1 over 3 cancel, negative 1 over 4 cancel. So starting here, both first and second terms will be getting cancelled. So this term will also get cancelled from something here. And this term will also get cancelled from something. So we are left with so this is our essay. This one comes from here. 1 over 2 comes from here. And everything else in between getting cancelled. So now S is limit n tends to infinity. So S is limit n tends to infinity Sn, which is 3/2. But this will goes to 0, goes to 0 as n goes to infinity. So S becomes limit n going to infinity 1 plus half, which is 3/2. So this is a new thing, which is known as telescoping sum. So what we learned is the test of divergence we cannot use, it doesn't say anything. Then we have to do the partial fraction. In partial fraction form, this is S. We express S as Sn. We will define Sn using a dummy variable. Define Sn using a dummy variable I and write it. And then we choose to stop. We choose to stop at n minus 1. Everything in between cancels out. We're left with only 4 terms as n goes to infinity. these two go to 0, you're left with 1 plus half.